Hello students, welcome to the Java class. Now we are going to see about sorted map. So what is a sorted map? So you can see in this diagram, sorted map is a child interface of map. So what is point number 1? Sorted map is a child interface of map interface. Next, when we should go for sorted map? That is, if we want to represent a group of key value pairs according to some sorting order of keys, then we should go for sorted map. That is, if we want to represent a group of key value pairs according to some sorting order of keys, then we should go for sorted map. Okay, so what is the next point? The next point is sorting is based on key but not based on values. So this is about sorted map. So next we have to see the methods of sorted map. So sorted map specific methods. So consider this map. So this is a sorted map. So 101 is the key and C is the value. 103 is the key and O is the value, and so on. Okay. So you can observe that this map is sorted according to the key value. So 101, 103, 104, 107, 125 and 143. So this map is sorted according to the value of key. Okay. Next, I want to apply some methods on this sorted map. So do you remember the methods of sorted set? So what was the first method? The first method was first itself. Next we had last. Next we had head set, tail set, subset. Similarly, here also, if I want to access the first key of a map, what is the method? The method name is first key. So what is the first key in this map? The first key is 101. So what this method is going to return? It is going to return the first key and the value is 101. Next, I want to access the last key in the map. I want to access last key in the sorted map. What is the method name? The method name is last key. So what is the last key? The last key is 143. So what it is going to return? It is going to return 143. Next, I want to access the head map. So method name is head map. So what this head map of 107 is going to return? It is going to return the map which is above 107, which is nothing but 101, 103 and 104. So it is going to return 101 is equal to C, 103 is equal to O and 104 is equal to R. So head map method is returning the map which is above the given entry, okay, which is above the given key in this case. Next is the tail map. So tail map of 107. So what is the tail map of 107? The tail map of 107 is, it includes 107, okay, 107, 125 and 143. So what is the mean by tail map? Tail map means the elements which are greater than or equal to the given key. So which means greater than or equal to 107. So that is 107 is equal to O, 125 is equal to N and 143 is equal to A. Next we have submap. So what is submap? So it is similar to subset, okay. So submap of 103, 125. So what it is going to return? It is going to return 103, 104, 107. It not includes 123. So that is, it is going to return 103 is equal to O, 104 is equal to R and 107 is equal to O. So which means greater than or equal to key 1 and less than key 2. Okay, this is key 1 and this is key 2. It is going to return the map which is greater than or equal to key 1 and which is less than key 2. Okay, next, and the next we have comparator method. So you know that why comparator is required? Comparator is required for customized sorting order. So what it returns? It returns the comparator object. Comparator method returns comparator object. So what if we are following default natural sorting order? If we are following default natural sorting order, then the comparator method returns null. Okay. If we are following default natural sorting order, in that case it is going to return null. So these are the methods which are specific to sorted map. So if I want to access the first key, what is the method? First key. If I want to access the last key, what is the method? Last key. Next, what head map is going to return? Head map is going to return the map which is above the given key, okay, which is greater than or which is less than the given key. So here I am passing 107. It is going to return all the entries which are less than 107. Next we have tail map. So what this tail map is going to return? It is going to return all the entries which are greater than or equal to 107. Next we have submap. Submap of key 1 comma key 2. What this method is going to return? This method is going to return all the entries which are greater than or equal to key 1 and which are less than key 2. Next we have comparator method. What this method is going to return? This method is going to return the comparator object. You know that comparator is required for customized sorting order. That object we are going to get. So what if we are following the default natural sorting order? If we are following default natural sorting order, then the comparator method returns null. So these are the sorted map specific methods. So you can note down the methods from here. So it includes even the return type. Okay. Now we have to see what is a tree map. So what is a tree map? So in this diagram, we can see that a tree map is an implementation class of navigable map. So just now we have seen what is sorted map. Still we have to see what is navigable map. So navigable map we will see in the next videos. So now we are going to see what is a tree map. So tree map is an implementation class of navigable map. So it is an implementation class. So there should be some data structure associated with the tree map. So what is the data structure associated with the tree map? The data structure name is red black tree. The underlying data structure of tree map is red black tree. So this is one kind of data structure. Next, what about the insertion order? The insertion order is not preserved in the case of tree map. Why it is not preserved? Because it is implementing sorted map. So whatever the elements we are adding into the tree, it will be sorted according to the values of keys. Okay. Yes, the insertion order is not preserved and it is based on some sorting order of keys. Next, what about duplicate entries? Can we have a duplicate keys? No, duplicate keys are not allowed. What about duplicate values? Values can be duplicated. That is the next point. Duplicate keys are not allowed, but values can be duplicated. The next 3 points are very important points. So what is the next point? That is, if we are following default natural sorting order, then the key should be homogeneous and it should be comparable. Otherwise, what we will get? We will get a runtime exception saying class cast exception. Okay. Next, what is the next point? That is, if we are defining our own sorting order by comparator. So if we are defining our own sorting by comparator, then keys need not be homogeneous and comparable. In that case, we can take heterogeneous and non-comparable objects also. Okay. So remember these 2 points, very important. These are with respect to the keys. Next, with respect to values. So that is, whether we are depending on default natural sorting order or customized sorting order, there are no restrictions for values. So we can take heterogeneous and non-comparable objects also. So remember this. Okay. Next, what about null insertion? So the null insertion is not possible as a key, but we can insert null as a values. So these are the important points with respect to the tree map. So what is the underlying data structure? The underlying data structure is red black tree. Next, what about the insertion order? Insertion order is not preserved and it is based on some sorting order of keys. Next, what about the duplicate keys? Duplicate keys are not allowed. What about the values? Values can be duplicated. Next, if we are following default natural sorting order, then key should be compulsory, homogeneous and comparable. Otherwise, what we will get? Otherwise, we will get class cast exception. Next, if we are defining our own sorting order by using comparator, in that case, keys need not be homogeneous and comparable. So we can take heterogeneous and non-comparable objects as a key. Next, whether we are depending on default natural sorting order or customized sorting order, there are no restrictions for values. So we can take heterogeneous and non-comparable objects as values. Next, what about null insertion? Null insertion is not possible as a key, but as a value, null can be inserted. Okay. Yes. Next, we have to see the constructors for TreeMap. Constructors of TreeMap. So TreeMap has how many constructors? TreeMap has 4 constructors. So what is the first constructor? That is TreeMap t is equal to new TreeMap. So what this constructor is going to create? This constructor is going to create an empty TreeMap object. So what is the sorting technique? Here it follows default natural sorting order. So this constructor is meant for default natural sorting order. So what is the second constructor? The second constructor is meant for customized sorting order. That is TreeMap t is equal to new TreeMap of comparator C. So whenever we are passing comparator object into the constructor, that means that we are following customized sorting order. So this constructor is meant for customized sorting order. So what is the next constructor? The next constructor is TreeMap t is equal to new TreeMap of SortedMap M. So why this constructor is required? So given any sorted map, to convert it into a TreeMap, we can make use of this constructor. Okay. Next, what is the next constructor? TreeMap t is equal to new TreeMap of map M. So why this constructor is required? That is, given any map, to get a equivalent TreeMap, we can make use of this constructor. So these two constructors, third constructor and fourth constructor, are used for interconversions. Okay. So given any sorted map, to convert it into a TreeMap, so we can make use of this third constructor. Next, so given any map, to convert it into a TreeMap, so we can make use of this fourth constructor. So, okay, these are the constructors of TreeMap. So next we have to see the examples for TreeMap. Now we have to see an example for TreeMap. So first I'm going to import java.util.star. Next, I will create a class called TreeMap demo. Next, within this class, I will define main method, public static void main string array args. So now I will create a TreeMap objects. So how to create a TreeMap object? That is TreeMap m is equal to new TreeMap. So what this constructor is going to create? This constructor is going to create an empty TreeMap objects where the elements are added based on the default natural sorting order. So remember that if we are not passing any arguments, to the constructor, by default it will take default natural sorting order. Okay. Next, I have to insert an entry into the TreeMap. What is the method to insert entry into the TreeMap? The method name is put. So m dot put of, so first I will add 100 comma z. So here 100 is the key and z is the value. Next, m dot put of 103 comma y. Next, m dot put of 101 comma say some x. So till now no problem. The key is homogeneous and also value is homogeneous. Next, what I will take is m dot put of 104 comma 106. Is this valid statement? What we are having? We are having heterogeneous values. So is the heterogeneous values is supported in the case of TreeMap? Yes, heterogeneous values are supported, no problem at all. Next, what I will take is, be very careful, m dot put of, I will take some f comma say some p. So is this allowed? If the sorting order is default natural sorting order, can we insert heterogeneous keys? No, heterogeneous keys are not allowed. So what happens if I try to add heterogeneous keys in the case of default natural sorting order? We will get a runtime exception saying class cast exception. That is CCE, class cast exception. Save this. I will compile and show java c. So what is the file name? TreeMap demo.java. So I will not get any compile time error, but when I run the program, what I will get? I will get a runtime exception saying class cast exception. So you can see here I am getting a runtime exception saying class cast exception. So why I am getting a class cast exception? Because here we are following default natural sorting order, but I am trying to insert heterogeneous keys, which is not allowed. So I will comment this line. So next what I will take is, so be careful, m dot put of, I will take null as a key, null of say some m. So what happens? Can I take null as a key? No, I cannot take null as a key. So what happens if I take null as a key? If I take null as a key, I will get null pointer exception. So save this program. So I will compile. So when I compile, I will not get any errors. So what happens when I run the program? When I run the program, I will get null pointer exception. So you can see here, I got null pointer exception. So why I will get this exception? Because I cannot insert null value as a key. Next. Next what I will do is, I will print the contents of the tree map. That is system dot out dot println of m. So now what will be the output? So this is a tree map. By default, it is following default natural sorting order. So what will be the output? Within the flower brackets, so that is 100 equal to z, comma, next 101 equal to x, comma, 10, what is that, 3 equal to y, yes, next 104 equal to 106. So save the program, compile. So when I run this code, what I will get? I will get this output. So 100 equal to z, 101 equal to x, 103 equal to y, and 104 equal to 106. So this is about tree map, and this is the example for default natural sorting order. So next we have to see customized sorting order. Okay. Now we will see an example for customized sorting in TreeMap. So first I'm going to import java.util.star. Next I'm going to create a class called customized, so cust TreeMap demo. Next, within the class I will define the main method, that is public static void main string array args. So within the main method, I will create a TreeMap object. TreeMap m is equal to new TreeMap. Okay. So now what this constructor is going to create? This constructor is going to create an empty TreeMap objects where the elements are sorted based on default natural sorting order. But what I want customized sorting order. So for customized sorting order, what I should pass? I should pass comparator object. So I will create my comparator class. So that is class my comparator implements comparator. Next, I should override which method? I should override compare method. You know that. Public int compare. So what I should pass? I should pass two objects, that is object obj1 comma object obj2. Next, now what I will do is I will define this compare method to compare string type of keys. Okay, So I'm going to compare string type of keys. So I will define string s1 is equal to obj1 dot. So I want to convert the given object into string. So how can I do that? I should call toString method. By calling toString method, the given object will be converted into the strings. Okay. Next, similarly, string s2 is equal to obj2 dot toString. So the given object is converted into string. So what is the objects? Objects are nothing but a keys here. Okay. Next, I want to sort the keys in a descending order. So what I will do is I will return. So what do you mean by descending order? I will call s2 dot compare to of s1. This we have already covered in our previous video. Okay. So s2 dot compare to of s1. So this is going to sort the given keys in a descending order. Next. So TreeMap T is equal to new TreeMap. Why I am getting confused with TreeSet? So TreeMap T is equal to new TreeMap. So I am not passing any arguments. So if I am not passing any arguments, by default it will take default natural sorting order. So I want customized sorting order. So what I should pass? I should pass my comparator object, that is new my comparator. So now the entries are sorted according to the descending order of keys. Okay. So first I will insert m dot put of. So since the key is strings, I will pass within double quotes. Okay. So x is a key and 10 is a value. Next, m dot put of. So I will take a is a key and 20 is the value. Next, m dot put of. Now I will take z comma 30. Next, m dot put of. Now I will take l comma say some 40. So now I will print the map entries. So how to print? System dot out dot println of m. So now what will be the output? The output will be, the entries will be sorted in a descending order. So what will come first? Z will come first. Z is equal to how much? 30. Next, x is equal to 10. Next, L is equal to 40. Next, A is equal to 20. So this will be our output. Save the program and compile. So compile. Java C. What is the file name? Customized TreeMap demo. Customized TreeMap demo.java. Next, no errors. Run the program. Java space customized TreeMap demo. So now what will be the output? The output will be z equal to 30, x equal to 10, l equal to 40 and a equal to 20. So this is all about TreeMap. Okay. So if you have any doubts, please contact me.